morning everyone, this is the introduction of Boyle's Law. First, who is Robert Boyle? Robert Boyle was an Anglo-Irish natural philosopher, chemist, physicist, and inventor. Boyle is largely regarded today as the first modern chemist, therefore one of the founder of chemistry. He is also one of the pioneer of modern experimental scientific method. He is best known for Boyle's Law. What is Boyle's Law? Boyle's Law is a gas law which states that the pressure exerted by a gas of a given mass kept at a constant temperature is inversely proportional to the volume occupied by it. In other words, the pressure and volume of gas are inversely proportional to each other as long as the temperature and the quantity of gas are kept constant.
For experimenting the Boyle's Law, we just need 3 things that you can see or look in your house. So firstly, we need a plastic bottle, a 2 pieces of balloon, and lastly, scissors. For the procedure, firstly, we need to cut the bottom part of the bottle. Be careful in handling the scissors. Next, we need to cut off the narrow opening of the balloon. Then use this to cover the bottom part of the bottle. And for the other balloon, put it inside and seal the rim of the bottle. And it's finally done. Now, slightly pull the balloon at the bottom of the bottle. And as you can see, when you pull the bottom part of the balloon, there will be increased volume gas inside and decrease the pressure outside and inside the bottle. This is very similar on how our lungs and diaphragm works. Boyle's law shows that as the volume of the confined gas increases, the pressure will decrease.
So let's solve this given problem. A 2.5-liter container has a gas pressure of 4.6 atm. If the volume is decreased to 1.6 liter, what will be the new pressure inside the container? First, let's find the pressure and volume. For the pressure one, we have 4.6 atm. And for the volume 1, we have 2.5 liters. This given problem, the P2 or pressure 2 is missing. And for the volume 2, we have 1.6 liters. So let's rearrange this using formula, which is P1 B1 equals P2 and B2. After rearranging, let's multiply it. 4.6 atm times 2.5 liter is equals to 11.5 atml. And don't forget to write the unit. So, let's multiply P2 and 1.6 liter. Since P2 is missing, 1.6 liter is the answer. And don't forget to put the unit. So use the 1.6 liters as a divisor. 1.6 liters divided by 1.6 liter is equals to 0 or cancel it. 11.5 ATML divided by 1.6 liter. Since the liter has the same unit, cancel it. And let's proceed to 11.5 divided by 1.6. It's equal to 7.19 ATM. So the pressure 2 is equal to 7.19 ATM, and that's the final answer.
So here's a problem. The air inside a flexible 3.5 liter container has a pressure of 1115 kPa. What should the volume of the container be increased to in order to decrease the pressure of 625 torr? So our P1 is 115 kPa. Our V1 is 3.5 liter. Our P2 is 625 torr, and our goal is to calculate or find our V2. So P1 and P2 need to have the same unit, so we will convert P1 to a torr value. So we need to know the conversion between kPa and torr. 101.3 kPa is equals to 1 atmosphere, which in turn is equal to 760 torr. So this is the conversion factor that we need. We're gonna put 101.3 kPa on the bottom and 760 torr on top. And we need to cancel the kPa unit. So it's 115 times 660 torr divided by 101.3. So that is equals to 860.8 torr. So now that is our new P1. So now we can now move to our next step, and now we can use the formula, which is P1 B1 is equals to P2 and B2. Our P1 is 862.8 torr. Our V1 is 3.5 liters. Our P2 is 625 torr. And so now we need to get the V2. So 862.8 torr times 3.5 liters is equals to 3019.8. Then make sure to copy the units. So 3019.8 is equals to 625. Now we need to divide both sides by 625. So cancel 25 and also the unit of torr. Now divide 3019.8 to 625, and that is 4.83 liters. So that is our B2.